Good day everyone, wherever you may be. Welcome to my channel, known as Physics and Chemistry Simplified. In today's lesson, we are going to be looking at a particular topic titled Particulate Nature of Matter. When we say particulate nature of matter, what do we refer to as that? This is a concept or an idea that matter is made up of what? Different particles. The concept or idea that matter is made of different That's what we mean by the particulate nature of matter. The concept or the idea that matter is made up of different particles is known as the particulate nature of matter. And these particles are discovered by scientists. And these particles in question exhibit random motion in the sense that someone is standing at the door of a laboratory and a reagent is open inside the laboratory. The person at the door post is able to smell the odor or perceive the odor of the reagent because of the what? Because of the random motion of the particles of what? Of matters. And what are these particles in question? And these particles are known as what? One, we have atom. Two, we have molecule. And three, we have air. So these three important particles, we are going to be taking them one after the other. Atom. Atom. What is an atom? An atom is the smallest particle of an element that can take part in a chemical reaction. The smallest particle of an element that can take part in a chemical reaction. Let me break this one further. For example, we have a solid element like a copper or zinc, and this copper or zinc is pulverized or grinded into a fine powder. The smallest part of these powdery substances that can take part in the chemical reaction is what we know as what? Is what we know as atom. Smallest particle of an element that can take part in the chemical reaction is known as what? As atom. Now to the second one. Molecule. Molecule. A molecule, just like an atom, is the smallest particle of an element that is capable of what? Of existing independently. And you can see the difference. Atom is the smallest particle of an element that can take part in the chemical reaction. Molecule is the smallest part of an element, smallest part of an element that is capable of existing independently. The molecule can be composed of atoms of the same elements. It can also be composed of atoms of different elements. What am I saying here? The molecule that is composed of atoms of the same elements. Example, we have nitrogen molecule. This type of molecule is composed of an atom of the same element. That is, two nitrogen atoms combining together to give what? The nitrogen molecule. That's it. Two nitrogen atoms combining together to give us nitrogen molecule. An example of a molecule of different atom is water, H2O. So we have two different elements here combining together to form a molecule of water. So we have the hydrogen combining with the oxygen to form a molecule of water. Hydrogen is having a valence of 1. Oxygen is having a valence of 2. When you interchange this valence, we now have what? H2O. So a molecule can be composed of an atom of the same elements, nitrogen, or an atom of different elements, which is what? Hydrogen and what? Oxygen. So this one, we now move to the third particles of the matter known as a ion. And what do we call an ion? An ion is an electrically charged atom. An ion is an electrically charged atom. It can be an atom or what? Or a group of atom. An electrically charged atom or a group of atom. And this ion we have what's it called? Different types of ion. We have the positively charged and the what? And the negatively charged ion. The positively charged ion is known as cation. Positively charged. While the negatively charged is known as what? Anion. Anion. It's known as what? Anion. So, an example of a positively charged ion, which is cation, is what we know as what? Cation. Cation is positively charged. In mathematics, whenever you see something like addition, it's like you are gaining. But in chemistry, it means what? Loss. For example, when you see something like this, positively charged potassium, it means that this potassium has what? Has loose an electron. Potassium has loose an electron. Potassium is the electron, and this is the potassium atom. So, looking at this now, you can deduce from what I've been saying this morning that this potassium has loose an electron. So, but if you are having something like this, chlorine atom minus, it means this chloride has what? Has gained an electron. It means the chloride has gained what? Has gained an electron. So it means the chloride has gained an electron. What is the psychology behind the gaining and losing of electron? What is the psychology behind the losing and gaining an electron? There is this trend among the elements in the periodic table All elements in the periodic table except the group O element want to satisfy the octet rule. That is, they want their outside electron to be what? To be filled up, therefore giving them what? Stability. So when we look at potassium is having a proton, 90 proton. And when you look at the atomose shell of potassium, you can see that the potassium is having how many electrons at the atomose shell? 1. For potassium to attain stability, it must lose that atomose electron to do what? To gain what? Stability. That is why potassium falls under the what? The positively charged ion. That is the type of an ion that's what? That lose an electron. Now when we come here, the chlorine is gaining an electron. Chlorine is what's it called? Belongs to the group 7 elements. And the group 7 elements usually have 7 electrons at the outermost shell. Therefore, they may want electron for them to gain what? Stability. Therefore, they are looking for that what? That electron by all means possible. So, chlorine atom now gaining 1 electron now, we allow that chlorine to be what? To attain stability, just like the what? Just like the group 7 elements. And lastly, before I round up, let's look at what we call atomicity. 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 Atomicity of an element. Atomicity of an element is the number of atoms that is present in one molecule of an element. Atomicity of an element is the number of atoms that is present in one molecule of an element. Number of atoms that is present in one molecule of an element. E.g., now we have oxygen molecule now. Oxygen molecule is referred to as what? A diatomic molecule. It's referred to as what? As diatomic molecule. Because of what? The presence of these two diatomic molecules. Oxygen can never exist alone like this. So it can only exist in 2 diatomic molecules. But we also have some elements that can, or some atoms that can exist as one. Those atoms we refer to them as what? Monoatomic molecule. Example is sodium atom. It's a monoatomic molecule. Monoatomic molecule. We have those that can exist like this. Triatomic molecule. We have those that can also exist as this. We call them tetraatomic molecule. And we have atoms that can exist from 5, 6, 7, 8, 9, 10 like that. Those we call them what? Polyatomic molecule. So this brings us to the end of today's lesson. But before that, let's do a recap. The topic, like I have said initially, was what? Particulate nature of what? Matter. I told us particulate nature of matter is a concept or idea that matter is made up of what? Different particles. And what are these particles? It's atom, molecule, and ion. We define these things one matter or the other. We mention what is an atom. An atom is the smallest particle of an element that can do what? Take part in the chemical reaction. I should give an example that, for example, if a solid element is grounded or pulverized into a powder substances, and a tiny bit of that powder, if it can take part in a chemical reaction, we can refer to that as what? As an atom. A molecule. Say molecule is also the smallest particles of an element that is capable of existing what? Independently. A same molecule can be composed of an atom of the same element, or an atom of what? Of different elements. Here I spelled out some example here on the board here, which is what? Nitrogen molecule. And this type of molecule is composed of what? Atom of the same element. Two nitrogen coming together to form what? Nitrogen molecule. And we also said the molecule can be composed of an atom of different elements. Here I gave you an example of water. Water is composed of a molecule of an atom of hydrogen and oxygen. Hydrogen has a valence of 1, oxygen has a valence of 2. When they interchange their valences, they become what? Water, which is what? H2O. Therefore, we move again to the ion, which we define as an atom that is electrically charged. It can be positively charged or negatively charged. So the positively charged ion, we call them what? The cation, while the negatively charged, we call them what? The anion. And there is also what we call the neutral atom. The neutral atom is neither positively charged or negatively charged. Why are they like that? Because of what? Their proton in the nucleus is equal to their electron surrounding the what? The nucleus. That's why they are called what? Neutral atom. That's why they are called neutral atom. They are neither positively or negatively charged because of what? Their proton is equal to their what? Their electron. And by so we move to what? We move to atomicity. Then we move to atomicity. We said an atomicity of an element is the number of atoms in one molecule of the elements. So here I spelled out some example. Sodium is a monoatomic atom. Monoatomic molecule. So we have oxygen also as diatomic molecule. We have ozone. We have what's it called? We have ozone. We have phosphorus. We have phosphorus. Phosphorus is a tetraatomic molecule. So we have sulfur. Also sulfur is a poly. It's a poly. I told you anything from 5, 6, 7, 8 is what we can refer to them as what? As polyatomic molecule. This brings us to the end of today's lesson. Please do well by subscribing to our channel here, so be able to be notified whenever another video comes up. Thank you. Be blessed.